Hey guys, so today's lesson is the law of cosines. We've recently worked with the law of sines, so we should understand that this type of trigonometry is used when we aren't dealing with right triangles. Okay, we're going to use this to solve triangles. Up until now, our trigonometry experience has brought us to a place where we can use a couple different methods. The first method we worked on was, well, really a long time ago, we did Pythagorean theorem, and that helped us when we had right triangles, but we didn't really deal with the other angles at all. However, we began recently our journey through right triangle trig, and we were able to use SOHCAHTOA to find the missing sides and angles based on what we know. So we know sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and the tangent of theta is equal to opposite over adjacent. Now, we used this to solve for missing sides, but we also used it to solve for missing angles. Please don't forget how to do that. We used trig inverse on both sides after we figured what my ratio was equal to. In certain cases, you're going to use trig inverse on random decimals, and that's okay. You did that in the angle of elevation and angle of depression section. So definitely don't forget about that. Okay, so after right triangle trigonometry, well, what other kind of triangles were we working with? We were working with oblique triangles. And what's an oblique triangle? Not a right triangle. That's really, in a nutshell, what an oblique triangle is. So we were introduced to those at the beginning of learning the law of sines. We broke law of sines into two main objectives, and we will do application problems in the future. The law of sines. Well, what kind of triangles could we use it on that are oblique? We saw it with angle-side-angle triangles, angle-angle-side triangles, and side-side angle triangles. Now, I was referring to those as angle side side because I think it's just something that will help you remember it. I'm not trying to be ridiculous, but we use the law of sines on these types of oblique triangles. In the first two triangles mentioned, we were solving for side lengths. And in the second triangle, the third triangle mentioned, side-side angle, we were solving for an angle first. We had to put the trig in the numerator and use trig inverse. Don't forget about trig inverse. If you randomly Google how to do that, it might call it arc sine, arc cosine, arc tangent, but I was referring to this as sine inverse, cosine inverse, and tangent inverse. So we have two videos up. One is for objective 1, where we were really doing angle, side, angle, 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 side triangles. And one was for objective 2, which is really side, side, angle triangles. I'll probably also redo the audio for that one because I've been having a lot of sound audio problems. Now, there's another two triangles that we need to know how to solve, and law of sines won't work for them. Those two triangles are side, 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 and side, angle, side. The way we're going to handle these triangles is using today's lesson, the law of cosines. The law of cosines kind of intimidates people at first because it does look like a long, heavy looking equation, but I promise you it's very deceiving. It's not so bad. When you're solving for angles with law of sines, which will be in the case that you have a side, side, side triangle, you do have to just be careful because there's going to be very tempting addition, subtraction problems. Yeah, more so subtraction. So watch out for that. Again, law of sines we use for angle, side, angle, 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 side, and side, side, angle triangles. Law of sines we're going to see today, side, 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 and side, angle, side. So like I began the law of sines lesson, you should definitely draw a triangle. We're going to label it with A, B, and C, just like we've been doing for the past few lessons. Obviously, the lowercase sides across from each angle are the corresponding lowercase letter. Now, let's look at what side angle side looks like. Side angle side would look something like this, where you had side C, angle A, and side B, and That's a side angle side. In the event that you have this type of side angle side situation, you're actually going to solve for the side across from the given angle first, okay? Keep that in mind. Side angle side, you'll solve for the side across from the given angle first. Now, a side triangle, I'll use a different color to highlight in this case, that would just really mean you're given all three sides. Okay, now if you're given all three sides, if it were a right triangle, you can use SOHCAHTOA and you can use sine inverse, cosine inverse, tan inverse to find your angles, but this is not necessarily a right triangle. These are oblique triangles, side. So we need to have a different way to do this. My advice to you, big time advice, is when you're solving a side triangle, you should always strive to find the biggest angle first, and don't forget the biggest angles across from the biggest side. All right, so let's get this law of cosine formula equation written down. Sometimes people have you write it down three different ways where they arrange A, B, and C in all three different ways. It looks like Pythagorean theorem at first. I have A squared equals B squared plus C squared. And again, remember, whatever letter I start with, in this case A, is going to be the letter of the side you are solving for, and it should be the letter that is the lowercase version of the capital letter angle that you have. So in the pink drawing on the paper and the pink highlight, I had angle A, so that's why I had the angle A, so that's why I'm starting the equation with lowercase a, side A, okay? So I'll fill in, there's more of this equation, I didn't finish writing it, but I will fill in the C, I'll fill in B, and I will fill in A in a moment. It's called Law of Cosines. I mean, I should probably have cosine somewhere in this equation, right? Oh yeah, another fun fact is the number one mistake I see in Law of Cosines is people use sine. So yeah, watch out for that. Okay, now minus 2BC comes next. So I like to think of the minus sign as a line of symmetry because there's this weird type of symmetry that I see, but you guys know how my head works at this point. And multiplication, careful, between 2BC cosine A, okay? Now, what is this symmetry I'm babbling about here? I have A at the beginning of my equation. I have A at the end of my equation. I have an equal sign. I have a cosine. Get it? I have B, C, and 2. I have B, C, and 2. And then my minus sign is my line of symmetry. Again, I apologize for my strange way of interpreting the world, but maybe it'll help some of you remember the formula for the law of cosines. Now, I'm going to write this formula in a couple different ways for you here so that we could just see how it would vary based on a different arrangement of sides and angles. Again, it really doesn't matter. You can interchange the A's, B's, and C's as long as you're consistent. If you change one B, you know, for an A, you have to change all the B's for an A, okay? So law of cosines, that's the generic one version of it. And let's write out how this would match to each case. So like I said, A in front for lowercase a would go with a situation where you're given angle A. If we were given angle B, on the other hand, if your problem was given angle B, it would look different. If we were using this setup for a side triangle, then that would mean I'm solving for angle A because, I mean, think about it, angle A is the only angle in my equation. So if that's what I'm solving for, well, then that's how I set it up. Let's look at another case. If we use b squared equals a squared plus c squared minus 2ac cosine b, that would just mean that my side angle side has me set up to either solve for angle B or side B. Okay, whatever the first or last letter is what you are looking to solve for. So I'm just showing in green over here. angle B, and I will also mark up the triangle next to it with green as well. So I would be given angle B and sides A and C, or side, A, B, C, and I'd be trying to solve for angle B. All right, little strange, makes more sense in application. If you understand it now, awesome. And last, in the event that we are solving for either side C or angle C, we will use this setup. And this will look like what I'll show you in purple. We'll have the sides A and B, and we will have or be looking for angle C or side C. All right, so C, angle C, side C, we start and end with C in our equation. If we're looking for angle B or side B, we start and end with B. And looking for angle or side A, we start and end with A. So the three equations are exactly the same. We just rearranged the letters. Our first example will be this one right over here. Example 1, we're going to use the law of cosines to solve a side angle side triangle. And in this example, we have side A equals 2, side B equals 3, and angle C equals 60 degrees. Okay, this is easily identifiable in a few ways. For most people, it would be with a picture. Side angle side, law of cosines, got it. For other people, it won't be noticeable that it's law of cosines until you make your column of capital ABC and your column of lowercase ABC and realize you don't have a pair of A's, B's, or C's. And for other people, it's obvious because you have A, B, and C all in your given information. Do you see A, B, and C, right? I'm going to label the triangle. I set it up exactly how I did in the most recent Law of Sines lessons. And I'm just going to highlight over what I do have here. A is 2, B is 3, and angle C is 60. Using the law of cosines formula, what we're going to do is we're going to solve for side C, which I'm going to highlight with the yellow highlighter. I have angle C, I'm looking for side C. The law of cosine formula that I want to use will begin and end with A, B, or C. Which letters? We're going to start and end with C because that's the angle we have, or the side, maybe you have, and that's the side we're solving for, or it's the angle we're solving for. Okay, so right now we're solving for a side, and we are solving for side C. I'm going to fill in the numbers we have, and it's really probably in your best interest, if you just really want to avoid any errors at all for this type of example, to type this straight across how I wrote it into a calculator. If you have like the type of calculator where you could see the whole entire screen nicely, type this in, make sure you're in degrees, not radians, and then you will basically what you're going to do now is then hit equals, get an answer, and then take the square root, because to get C alone, you take the square root, right? But when we're solving for the angle, which you'll do in a few examples, when we're solving for angles, it is actually a little bit more, you want to show work more. So I'm going to proceed with showing work, and there's also going to be this very sneaky, tempting situation, because every time you have your, say, a squared plus b squared, whatever you get for that number, and then whatever you get for 2ab, it's going to look real good to want to subtract those values, you know? So 2 times 3 is 6. 2 times 6, well, that's really 12. So I'm just going to write a 12 cosine C. And 4 plus 9 is 13. This is what I'm talking about. Like 13 minus 12. It's just taunting you, you know? Subtract me, I know you want to, but really you can't. That 12 is attached to the cosine C. We can't subtract them, okay? No matter how badly you want to, you can't do it, okay? Cosine of 60, you could do that in a calculator if you want, but the cosine of 60, you'll get, if you punch it in the calculator, you'll get 0.5. And 0.5 really means half, and multiply means of, so you're really looking for half of 12. And then from there, 13 minus half of 12, or 13 minus 6, leaves us with 7. C squared is equal to 7. You do an inverse operation, just like every single step of algebra you do. You guys really got to think about this. You are using inverse operations all day. Inverse of squaring is square root 7. Beautiful. If I need the decimal value of square root 7 for some reason, I will bust out my calculator and I will take the square root of 7 and I will round it according to whatever the directions ask me to do, okay? And if you do that, you get approximately 2.6-ish for the square root of 7, okay? Now, when I do the other work, I do use square root of 7 in my calculator. I'm not pulling the calculator under the camera now because I'm trying to do this all in one shot on my old computer. Sorry. And the lighting gets weird when I put the calculator under, so I'm just doing that off camera, okay? I've done it under camera many times for you guys already. Now, I should have written out my list of A, B, and C from the beginning. This should have been done, but I'm doing it now. And you see in the original information, I did not have the pair of letters that would allow us to do law of sines. That's why I had to use law of cosines. But now that I've found side C, any third thing I found would really give me a pair if you think about it. But you know, we only have a set way to find side C. We found it, rad 7 or 2.6, whatever you wrote. I have a pair of C's. I can use those for my law of sines. And I'm going to go ahead and find angle A. You can really find A or B, it doesn't matter, whatever one you'd rather do. So up here, I'm just going to set up, remember, we're solving for an angle, so sine is going in the numerator. Sine A over 2 equals sine 60 over radical 7. Now we need to multiply both sides by 2. And this number 2, sine 60 over square root 7, is a number you can calculate in the calculator. Go ahead, type that in, get that decimal. Once you get that decimal of 2 sine of 60 radical 7, my calculator said something like, I think it was radical 21 over 3, I believe. Actually, I think I still have it on my screen. Yes, radical 21 over 7. And when I go and want to get A alone, how do you get rid of any operation? You use the inverse operation. What is the inverse of sine? Sine inverse. So all I did was take sine inverse of that right side. Do the right side, get a decimal. I got 40.89 degrees or 40.9 degrees. Now just a quick freeze frame. If you have two angles, how do you find the third angle? Add what you got and subtract it from 180. What does that leave you with? Well, you had 60 and 40.9, so angle B must be 79.1 degrees. So what's the big takeaway? Big takeaway is that you will begin a problem using law of cosines under the conditions of being given a side angle side or side 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 triangle. Once you use law of cosines to find either the largest angle, that's my advice for example 2, or the side across from the given angle. But once you do this with your law of cosines, there's no need to use law of cosines twice. You'll have enough information to finish the problem with the law of sines. Sidebar, the reason you use the law of cosines to find the largest angle in an example like example 2 is because that will ensure that you don't get stuck doing the ambiguous case with law of sines on a triangle, because that's when they sneak up on you when they're mixed into a law of cosine problem. Okay, so here, my advice, I just mentioned it again a second ago. When you're given a side, side, side triangle, definitely using law of cosine, find that biggest angle first. Now, if I just go ahead and use the first formula I wrote down for law of cosines, it's not going to have the letters in the right way because I have A, B, and C in my problem. You know, I'm better off writing it the right way first for the variables that I have. What am I talking about here? So C is my biggest side. Do you see that C is equal to 6 units, whereas the other two sides are 4 and 3? the side length of 6 units will be definitely across from the largest side. And the only way you could get an obtuse angle is with cosine. You don't really understand why yet if you're in geometry. If you're in pre-calculus, however, you should know why. So I'm going to reset this equation, except I'm going to begin with a lowercase c value, and I'm going to end up with a capital C angle at the end of my equation. And this way I know I'm solving for angle C using my law of cosines, and I will be avoiding ambiguous case with my law of sines. You're welcome. This was like magical golden advice, okay? Again, side, side, side triangle. Find the largest angle first, and the largest angle is across from the longest side. So I'm rewriting my equation formula with C on both ends. Biggest mistake I see also is that instead of using cosine in law of cosines, people use sine, so watch out for that. And also don't forget about this tempting a squared plus b squared minus 2ab situation. Definitely be careful. We're going to combine a squared and b squared, subtract it to the left, and then we're going to divide by the negative 2ab, then we'll take cosine inverse. I know, a lot there. If you want to rewind, write those steps down so you're ready for them. Go ahead, rewind, and then I'll see you in a second when you catch up. Otherwise, if you fill in what we have, we'll have 6 squared equals 4 squared plus 3 squared minus 2 times 4 times 3 cosine C. 6 squared is 36, 4 squared is 16, 3 squared is 9, minus 2 times 4 is 8, and 8 times 3 is 24 cosine C. 16 plus 9 is 25, and 25 minus 24, there it is, so tempting, you know, it just wants you to subtract them, but you cannot do that. So we're going to subtract 25 from both sides. 36 minus 25 brings us to an 11. Do not lose that negative in front of that 24, okay guys? Big, big, big spot. Don't lose it. Negative 24 cosine C. Now we need to divide both sides by negative 24. Cosine of C equals negative 11 over 24. How do you get an angle? How do you get rid of cosine, guys? What is it? What do you do? I know you know. What do you take? You don't divide by something. You take the cosine inverse of that negative 11 over 24. Beautiful. We're going to put this in the calculator. When we put this in the calculator, cosine inverse of negative, not minus sign, 11 over 24, we get 117.3 degrees. Now we have a pair of C's. From here it should be fairly simple. You're going to do the law of sines to find the next angle, and you only need to do it once because once you have two angles, you just subtract from 180 to get your third angle. Okay, so it should be pretty simple at this point. All right, we're using the C's for one pair, and let's use, whatever you want to use. A, you want to use B, let's use A. Sine A over 4 equals sine of 117.3 over 6. I don't know why I wrote it like this. Sorry. Multiply both sides by 4. We're going to punch that in the calculator, and after I just do the 4 sine 117.3 over 6 in the calculator, I get about 0.59, and that's the decimal value that you're taking the sine inverse in for the next step. All right, so the angle A will be equal to the sine inverse of 0.59. Really use the number that's on your calculator screen, or really just leave it as 4 sine 117.3 over 6. And you should get about 36.3 degrees for angle A. And then all you need to do is add those two angles that you already have together and subtract from 180 to get angle B. Big finish, angle B is equal to approximately 26.4 degrees. And that's the end of our two examples. Here are two homework problems for you to give a try. They are set up exactly like the two lesson examples. The first one we have is a side angle side example, and then a side, side, side. And do not forget the advice given. So if you're looking for a side, you set it up so that the letter leading the problem is the side across from the given angle. And if you're solving for an angle, solve for the largest angle, and that would be the one across from the longest side. Good luck. Hope this helps.